Welcome to the 13th century Konark Sun Temple. Sitting right on the edge of the Bay of Bengal, sailors navigating these waters used to call this massive stone structure the Black Pagoda. It's a gorgeous location, but it's an absolute nightmare for a building. The structure is constantly battered by high winds, suffocating humidity, and relentless salt air. Most of the temple is built from condylite. That's a type of metamorphic rock formed under intense heat and pressure, but it has a very porous structure, making it highly vulnerable to that corrosive salt and wind. Today, keeping these massive masonry walls from totally collapsing requires extreme engineering. Conservation teams use precision, vibration-free core drilling just to stabilize the interior without shattering the delicate facade. Despite centuries of effort, the stone of the Black Pagoda is steadily losing a war of attrition against the coast. But hidden inside that decaying rock is a massive architectural anomaly. The original builders reinforced the temple using heavy iron beams. You can see the beams right here. They have been sitting in this exact hypersaline environment for over 700 years, yet they are structurally solid and almost completely intact. This caught the attention of material scientists, because iron exposed to coastal air should turn into a pile of rust in a matter of decades, let alone centuries. This data visualization compares oxidation rates. The Konark iron demonstrates corrosion resistance almost 2 orders of magnitude higher than modern steel. Projected on a timeline, a contemporary steel beam in these coastal conditions would have dissolved centuries ago, while the ancient metal holds its ground. So how exactly did medieval Indian builders manufacture rust-proof iron long before the Industrial Revolution? The answer lies with the people who built it. The Odia people of 13th century India possessed incredibly advanced scientific capabilities for their time. Their architecture proves their mastery of astronomy. The 24 intricately carved stone wheels around the temple are actually high-precision sundials, capable of calculating the exact time down to the minute based on the sun's shadow. They were also elite navigators. Odia mariners mastered complex wind and ocean currents to build a massive global trade network, stretching as far as Bali and Sumatra. When a society is that precise with their astronomy and navigation, a rust-proof structural beam is no lucky accident. It is deliberate and highly calculated engineering. To figure out how they did it, an investigative team at IIT Bhubaneswar, led by Professor Subhan Verpati, launched Project Forging the Past. Because the beams are priceless historical artifacts, the team relies on strict, non-destructive methodologies. They use portable diagnostic machines directly on site, ensuring the ancient iron remains completely physically unaltered while they scan its chemical makeup. This radar chart maps both materials. For ductility, the ability to bend, and weldability, modern steel easily wins. But plotting chemical resistance to rust, the 13th century iron utterly dominates modern blast furnace output. This specific composition represents a sharp metallurgical trade-off. While the resulting beams lack the versatility and flexibility of modern steel, they possess a near invulnerability to corrosion, effectively prioritizing extreme longevity over all other properties. The investigation at IIT Bhubaneswar is now focused on a more ambitious objective, reconstructing the ancient iron-making laboratory itself. This effort is backed by the Indian Knowledge System, specifically through their competitive grants program, which funds interdisciplinary research into historical technologies. They are treating history like an R&D department. The objective is to extract this lost metallurgical technique and apply it directly to modern problems. The real-world implications of reviving this technique are massive. Corrosion costs the global economy billions of dollars every single year. Imagine a future where suspension bridges, cargo ships, and coastal skyscrapers are forged with a material that naturally repels rust, remaining structurally sound for centuries without toxic chemical coatings. For hundreds of years, legends claimed the Black Pagoda housed a giant magnet that pulled passing ships to their doom. The science tells a much more impressive story. Ultimately, the 13th century builders left behind a practical legacy more significant than any legend, an engineering blueprint for survival, waiting to help us build a permanent future.